Hello, welcome. My name is William. I come from Southern University College, and today I will introducing our innovations. A real-time AI-powered palm oil disease detection system just by using each device. This solution helps a smallholder farmer to identify the multiple disease of a palm oil of unhealthy conditions without internet access. This innovation using Raspberry Pi 4B or 5 to run the process, a camera and a deep learning method. Malaysia palm oil support over 450,000 of families in these smallholder farmers. However, the diseases like Ganoderma Basal Stem, Curvularia, and also will include nutrient deficiency like potassium deficiency, boron deficiency. These can lead to economic losses up to 1.5 billion ringgit Malaysia annually. The traditional method or techniques that identify the disease and also nutrients, it takes longer and also slow and not suited for smallholder farmer with no internet because some of the rural areas without internet. This solution is unique because it uses a mobile net V3 large deep learning as a lightweight transfer learning in the deep learning method, deployed on the Raspberry Pi 4B as a processor. To run through this deep learning process, it works offline, offer real-time detections. The costs just under 500 ringgit and it achieves
99.88% of accuracy
to detect the disease detection system. And also within 1 second, it can have a feedback of these disease classification. Without further ado, let me show you how it works. So this is an innovation device that can capture and detect the disease system of the palm oil. So we can use this to capture the image of palm oil disease and also can go for stem and also can detect the nutrient deficiency. So this is a 5 megapixels of a camera that can capture and also live feed to the Raspberry Pi system. This can instantly predict the disease that appear on the palm oil. Is it unhealthy or healthy conditions? Now let me show you how it works. Okay, first, when we find a disease that appear on a leaf or just on the stem, it comes over a leaf. So when we find a disease, let's find it out. So for example, this is the nutrient deficiency. You can see that the leaves have a wrinkle symptoms. So is it nutrient deficiency or just a disease occur on this? Let's try it out on our system. Now let's check out how the system can predict this disease or just nutrient deficiency. I don't know. Let's check out. So for better demonstration, I will use this screen, 10-inch screen, to demonstrate and display on this for better demonstrations. So this is a demonstrations display about of this system. So this is a camera feed that can live feed, and also you can click this predict to get a confidence rate of accuracy, and then also you can set about a threshold to check whether it's accuracy threshold setting, and then this you can change the save directory, which means you can save the image or just load the image, and this one is refresh button to refresh everything. Let's check about this symptom. The camera position on the leaf and click for this, it show boron and the accuracy is 98.9%. If you don't believe, you can clear and predict again. Show 96.8 for this boron. Let's check another rotation. It show boron again 98.7%, and it also show boron deficiency and give advice. Apply a boron fertilizer 4.5 to 7.5 pH to maintain the pH of a soil. And then there has a symptom about hook leaf and crinkle leaf. You can see that this leaf really have a crinkle. And then our prediction have a history about this. You can see that all the confidence history, and you can export this history to Excel and also save the result of image. You can refresh again and load, open, and it shows 98.8% for this boron disease detections. Behind of me, this tree have a critical disease occur, and you can see that it appear about this hole. So actually, what is this? I think a lot of the smallholder farmer don't understand what is this also. You can see that they have a lot of holes. What will this happen? Let's check with this system. We go to predict again. It shows PSR 3. So this is Ganoderma Basal Stem Rot, and it also gives advice: isolate infected palms, remove debris, sanitize. Consider a surgery for the early stage. Focus on the prevention by good sanitation. Let's check again. It also shows BSR have a 94% of accuracy. By using this edge device or this system, actually this system can prove you the prediction of the accuracy of high accuracy for this. It shows that 95 above % for this healthy stem. And also the system advice to maintain the tree by put the moderate pH value and also take care about the nutrients to maintain the tree healthy conditions. So this information improve productivity of this palm oil to increase the economics and also reduce the losses to this economic source due to the crop loss reduces, and also empower the rural farmers with this affordable technology device. So well, how about contributions? The contribution actually it contributes to 3 categories of the SDG, Sustainable Development Goals, which is SDG 9, Innovation in the Rural Areas, SDG 15, Forest Conservation. So for Technology Readiness Level, TRL, it reached level 6, which is technology demonstrated in this agriculture area. With this device, it also comes to economic market potential, right? With over 1.48 million hectares of this agriculture land that managed by smallholder farmers in this Malaysia, this capable solution has a huge commercial potential. It also can be expanded to cocoa, banana, or rubber plantation, and also can be copyright and licensed to the agriculture government or also other corporate such as NGO, agriculture technology firm, and also MPOB for these palm oil disease detections. So with this supporting evidence, we
Train
trained
the model with 16,920 images and data splitting into a ratio 7:1.
it detects 6 conditions with a high precision and recall. Here's the confusion matrix showing a minimal misclassifications. Deployment has been tested in collaborate with Nila Hasil Sdn Bhd.
Nama saya Andy. Saya sudah kerja sini 10 tahun jaga sawit dalam company Nilai Hasil. Kebun ini pokok sudah ada 15 tahun. Pokok ini dulu kurang sehat dan kita tak tahu penyebab dia. Bos ada cari konsultan, tapi kos mahal. Konsultan bagi arahan, kita ikut. Tapi pokok masih lama masalah. Bos ada bagi konsultan baru guna teknologi ini. Produk ini memang boleh selesai masalah dengan cepat dan kos rendah.
Kampung Pantai Layang Johor, approximately 3,600 trees supported by Nila Hasil Sdn Bhd. Our system achieved a remarkable 99.88% accuracy with an inference time 750 milliseconds per image and precision range around 0.92 to 0.98 across a 12 identification classes. So once again, for the supporting document in our solution is fully portable, offline capable system that identifies multiple healthy and unhealthy conditions in the palm oil trees in real time. Built as a working prototype as a TRL level 6, it's been field tested on 80 acres plantation in the Kampung Pantai. Let's dive into the performance details. In this table showing that the precision, recall, F1 score and support for 12 classes. For example, boron deficiency, potassium deficiency, and BSR and others. Overall accuracy is 99.88%, validated on a test set of 1,692 samples. Is the accuracy evolution graph on the right side and also loss evolution on the left that demonstrate a model have a very good high level and also loss decreasing over each epoch. Then, for the confusion matrix, provide a detailed breakdown of the model classifications. A very strong diagonal of a high number on diagonal is consistent across most classes, significantly strong predictive accuracy. Metric show minimal error with only 2 of diagonal entries such as 1 BSR moderate tested, 1 BSR moderate test sample was inaccurate, identified as healthy stem test, and 1 healthy stem test sample was inaccurate, identified as BSR moderate test. Next, let's move on to our solution architecture. So the diagram illustrates the pipeline. Images of the palm leaves of stem are captured by camera, processed through our TensorFlow-like model, and classified into one of the 12 health conditions with result displayed instantly. The system is optimized for low power edge device, ensuring scalability and usability in a remote area without internet access.
Thank you for watching. I believe that this device AI-powered disease detection system that can revolutionize the agriculture and support the smallholder farmers across Southeast Asia. Let's innovate for sustainable future.